Hi, this is Dr. Pan, host of Tucson Math Doc channel on YouTube. We have a very interesting problem here to solve by implicit differentiation. Implicit differentiation, that's just saying treat y as x. Okay, we don't have specifically say y equal to x squared to take derivative for. Implicit means x and y is kind of jumbled together, but in the process of taking differentiation, you got to treat a y as a function of x. Okay, so let's get started. On the left-hand side, when we take derivative of e, it's by itself. Okay, and then we got to take derivative of x over y. Let's just put a prime in there for now. On this side, we have 9, which is easy. Now remember y, I tell my student put a dot on the bottom. So dy dx. Okay, so it's really 1, and then y itself is a function of x. So you have to do dy dx. Okay, now let's leave that alone. Let's do the x times y to the minus 1 derivative. Okay, the reason I write it into the multiplication, it's a little easier than doing a derivative for a product. Product is a little easier than a quotient. So derivative of the first one, which is 1, leave the second one alone, plus derivative, leave the first one alone, and then you're going to take derivative of the second one, which is y minus y to the minus 2. Now remember, y is the one you're taking derivative for. You do have to take the chain rule again. Okay. Once again, derivative of first one, which is 1. Leave the second one alone, which is this one. Leave the first one alone. Derivative of the second one, which is minus 1 y to the minus 2. Then one more term. This is the term that's the implicit differentiation. Okay. All right, let's get it back in there. So we have e to the x to the y. Okay. Derivative for this chunk here is where we calculated over there. It's 1 over y plus x over y squared dy dx equal to 9 minus dy dx. I'm going to gather all my dy dx together so I can have a y prime, basically. Let's multiply this one out. It's a little messy, but let's write it slowly and carefully. That's the first term, plus e to the x to the y times x divided by y squared. There's a dy dx for this term, okay, equal to 9 minus dy dx. Let's combine our dy dx together. So I'm going to move this one over. So I have, and that's one over on that side. So it's 9 minus e to the x to the y, okay, divided by y. On this side, I'll have dy dx. Okay, so this term, which is e to the x over y times x divided by y squared minus, actually plus 1. Okay, let's see. So what I did is I moved this one over there, which becomes the plus 1. I moved this one over, which is 9 minus the whole thing. Okay, one more step, dy dx. Well, I might have to simplify a little bit, but dy dx equal to this chunk, which is 9 minus, let me make sure I didn't forget a minus sign here somewhere. I have a feeling I forgot a minus sign over here. Yep, this one is a minus. This is a minus, which means this one is a minus sign. That one has a minus sign, so let's see, that's a minus sign here. Okay. All right. 9 minus e to the x over y, the whole thing divided by y, and the whole chunk is divided by what I have over here. 1 minus e to the x over y times x divided by y squared. Wow, that's a complete mess. Let's multiply by top and bottom by y squared, so at least we don't have the fractions stacked on top of each other. So we have dy dx is equal to 9y squared minus y times e to the x over y divided by y squared minus x times e to the x over y. Okay, so here's our answer. Now to review a little bit, so implicit differentiation is just every time you take derivative of y, you got to do the dy dx, treat it as a function of x. So you got to use chain rule one more time. That's all it says. Now I know this chunk is pretty messy, so I wrote it on the side and trying to keep track of my minus sign. Even then I missed the minus sign for a little while. Okay, you guys saw it. So then once I found it, I put it back in there and double checking. So it's 1 over y, this is minus. Okay, I have all the signs correct. And then I collected all the term that has dy dx together. So dy dx, this is plus 1, this remains minus. And then I moved all the things that doesn't have dy dx onto one side. So dy dx equal to this doesn't have divided by the coefficient for the dy dx. And the last thing I did is I simplified it just one more step. To make it a little prettier, so it's dy dx times y squared, so now y squared minus y, because the one of the y cancels. And then on the bottom I have a y squared, and a y squared cancel, that's just x. Alright, hope this helped. Have a confident day.